We follow the discussion of the logistics in the production and construction phase up with a review of logistics in the utilization and support phase. Figure 8.1, that is figure 1 of chapter 7 in the Pearson New International Edition, shows the interrelationship between the different system lifecycle phases. We have encountered this in more detail in figure 6.2, that is figure 2 of chapter 5 in the Pearson New International Edition. This was in session 2 on systems engineering. This simply shows that the lifecycle starts at the need, then the system is designed and developed, and then manufactured and used. Later it is disposed of. The other thing that this shows is the design for supportability follows later than the design for production. That is, it is phased later. And the design for disposal follows even later. It also shows that all of these processes have feedback that affects and thus improves next generation system design. Figure 8.2, that is figure 2 of chapter 7 in the Pearson New International Edition, shows the extended use of results data from the use of the system to modify the systems in the field, if required. As the system is used and tested during field operations, data is collected, which can be used to understand the system's response to the production environment. This raw data is retrieved and analyzed. The results of this analysis is saved in a results data bank and is used for two purposes. The first of these is to take this data plus any requests received to start building a base for the development of an improved new generation system in future. The second is to identify problems in the present production situation that needs to be addressed. If the system has a problem history and corrective action has been taken based on that history, it means that the problem has not been resolved and the corrective action taken in the past needs to be re-evaluated. On the other hand, if the system does not have a problem history, or if corrective action was not taken in the past on a known problem history, then the problem should be evaluated. If this problem evaluation is done and it is found that no corrective action is necessary, then leave the system as it is. Otherwise, initiate planning for the required corrective action, which will involve a system modification, which is then incorporated in the system and the data bank updated. Figure 8.3, that is figure 3 of chapter 7 in the Pearson New International Edition, shows typical measures used to evaluate system performance. The first shows the maintenance labor hours per system operating hour. One expects that to reduce as the program gets more experience and improves the equipment in the field through modifications. The second shows the percentage of the system maintenance labor hours per system operating hour attributed to different subsystems. This puts the focus on those subsystems with the largest contribution to the labor hours. In this case, subsystem E, which contributes 31.7% of the total. This can focus one's mind on improving this subsystem for future generation systems, as well as where effort should be expended when considering modifications of present generation systems. The midpoint on the y-axis here is the minimum mission reliability required. In this case, the system has exceeded the requirement in periods 1, 4, and 5, but did worse than that in periods 2 and 3. This can assist one in identifying reliability problems and can lead to improved designs. This graph can assist one in identifying what level of inventory should be maintained. This then ends session 6 on the subject of logistics from the development to the retirement phase.